Hello students, in previous class we discussed about refraction of light at curved surfaces. Today we are discussing how do rays bends when they are incident on a curved surface. As in the case of plane surfaces, a ray will bend towards the normal if it travels from rarer medium to denser medium, and it bends away from the normal if it is traveled from denser to rarer medium. So in 9th class, refraction of light at plane surfaces, in that we discussed a ray which is travel from rarer medium to denser medium. In that, refracted ray is moved towards the normal. Okay, so if it is travels from denser to rarer medium, then the refracted ray is bends away from the normal, that we discussed. So let us see how we can draw the ray diagram for certain useful cases. So let us see how can we draw the ray diagram for certain useful cases. What happened to the ray that travels along the principal axis? Similarly, a ray that travels through the center of curvature. So what happened to the ray that travels along the principal axis, and similarly a ray that travels to the center of curvature. Here, according to Snell's law, the ray which travels along the normal drawn to the surface does not deviate from its path. Hence, both the rays mentioned above are travel along the normal so that they do not deviate. So here the ray which is traveling in the direction of center of curvature does not deviate its path. At the same time, the ray which is travel along the principal axis also does not deviate its path. Okay, so they do not deviate. So what happened to a ray traveling parallel to principal axis? So observe the following figures: 4th A, 4th B, 4th C and 4th B. In all the cases as represented by the ray diagrams. So in this 4th A, 4th B, 4th C, 4th D, we can observe that rays are traveling parallel to principal axis. Okay, so then what happened to that rays that are represented by the diagrams? Okay, so in this, incident ray is parallel to principal axis. Okay, so this 4 diagram shows that the incident rays are parallel to principal axis when they are incident on a curved surface. Then what happened about that, this will explain. Case 1, a ray traveling parallel to the principal axis. Okay, once you observe the incident ray, okay, the ray traveling parallel to the principal axis and strikes a convex surface, and passes from rarer medium to denser medium, Okay, once you observe, here one curved surface is there, one principal axis is there. Okay, so curved surface outside, that is rarer medium, and that black curved surface inside black colored portion is there, that is called as denser medium. So here one ray is there, that ray is traveling parallel to principal axis, means incident ray is traveling parallel to principal axis and strike the convex surface, and it passes from rarer medium to denser medium. Okay, next, case 2 means 4th B, figure 4th B. Once you observe, in that a ray traveling parallel to principal axis, strike the convex surface and passes from denser medium to rarer medium. Okay, so in figure 4th B means, that is case 2. In this we can observe one curved surface. Okay, so in that curved surface, left side black colored portion is there, means that is denser medium, and the curved surface right side white colored portion is there, that is rarer medium. Okay, so here ray traveling parallel to principal axis. Once you observe in denser medium, one on principal axis one ray is there, that is called as incident ray. Okay, so that ray traveling parallel to principal axis. Okay, incident ray traveling parallel to principal axis and strikes the convex surface, and it is passes from denser medium to rarer medium. Okay, next, case 3. Okay, case 3 means figure 4th C. Here curved portion is there, curved portion right side black colored portion is there, curved surface left side white colored portion is there, means that black colored portion is called as denser medium, this white colored portion is called as rarer medium. So here Principal axis is there, no? On principal axis one ray is there. Once you observe the arrow mark, okay, so means that is the incident ray. Okay, so here a ray traveling parallel to principal axis, a ray traveling parallel to principal axis strikes the concave surface, okay, strike the concave surface and passes from a denser medium to rarer medium. Okay, so here in this denser medium on principal axis one ray is there, that is called as incident ray. Okay, so here the ray traveling is, the incident ray is traveling parallel to principal axis and strike the concave surface and it passes from denser medium to rarer medium. Okay, next case 4 means figure 4 to D. Once you observe here, a ray traveling parallel to principal axis and strikes the concave surface and passes from rarer medium to denser medium. Okay, na? So here one curved surface is there, curved surface left side, denser medium is there, curved surface right side, rarer medium is there. So here on principal axis upside we can observe the incident ray. Okay, so this ray traveling parallel to principal axis and strike the concave surface and passes from rarer medium to denser medium. Okay, so what difference do you notice it in the refracted rays in 4th A and 4th B? Okay, is there any difference we can observe in the refracted rays in figure 4th A and 4th B? Do you know what is the refracted ray? What is the meaning of refraction? When light falls on a curved surface. Okay, the light that is entering, when the light entering from one medium to another medium, it is changing its speed as well as direction. That concept is called as diffraction. Okay, so here when the light entering from one medium to another medium, there we should draw one perpendicular line, that is normal. The angle between the incident ray and normal is called as angle of incidence. The angle between the refracted ray and normal is called as angle of refraction. Okay, the ray which is incident on a surface, that is called as incident ray, and the ray entering into another medium, that is called as refracted ray. So did you observe any difference in the refracted rays in 4th A and 4th B? Okay, what could be the reason for this, for the difference, and what difference do you notice in refracted rays in figure 4th C and 4th D? What could be the reason for the difference? Okay, once you see here, do you observe any difference in the refracted rays in 4th A and 4th B? What could be the reason for that? And did you observe any difference in the refracted rays in 4th C and 4th D? What could be the reason for that difference? Now we will discuss. So here you might have noticed that in figure 4th A and 4th C, in figure 4th A and 4th C, refracted ray reaches a particular point on the principal axis. In figure 4th A, once you observe the figure 4th A and observe the figure 4th C, in this refracted ray reaches a particular point on the principal axis. Yes or no? Yes. Once you observe the picture 4th A and 4th C. Next, in figure 4th B and 4th D, the refracted ray moves away from the principal axis. Okay, in figure 4th B and 4th D, once you observe the figure 4th B and 4th D, okay, in the refracted rays move away from the principal axis. Okay, when you extend the refracted rays backward along the rays as shown in the figure 4th B and 4th D, the extended rays intersect the principal axis at some point. In 4th C, B and 4th D, refracted rays move away from the principal axis. Yes or no? Yes. So extend the refracted rays backward along the ray as shown in the figure 4th B and 4th B. Then what happened? That intersect the principal axis at one point. Okay. So in 4th B and 4th D, refracted rays move away from the principal axis. If we extend the refracted ray backward, then what happened? That meet the principal axis at some point. Okay, the point where the refracted ray intersect, the point where the refracted ray intersect on the axis in all the above cases is called as focal point. Okay, so the point where the refracted ray intersect the axis in all the above cases, it is called as focal point. You might have observed that a lemon in a glass of water appears bigger than its actual size when we view it from side of a tumbler. How can you explain these changes in the size of a lemon? It can be explained by using the refraction. Okay, so when the light travels from one medium to another medium, it's undergo refraction. So is the lemon that appears bigger in size an image of lemon, or it is the real image, that is the image of the lemon? We will discuss about image formation. Okay, consider a curved surface separating two medias of refractive indexes n1 and n2. It's shown in the figure. Once you observe the figure, this curved surface is separating the two media, that refractive indexes are n1 and n2. A point object O is placed on the principal axis. Consider a point object is placed on the principal axis at a point O. At this point O, one object is placed on the principal axis. Okay, so the ray which is travel along the principal axis passes through the pole and deviate. So from the point O, one ray that is traveling through the principal axis, it does not deviate, it follows the same path. Next, the second ray which forms an angle alpha with the principal axis meet at a interface at A. Okay, so one ray from the object O, one ray traveling parallel to the principal axis, it does not deviate, and one more ray that is making some angle with the principal axis alpha, and that meet the convex surface at one point A. Okay, here the angle of incidence is theta 1. Angle of incidence is theta 1. Okay, now the ray bends and passes through the second medium along the line A. So at the convex surface, the ray, incident ray fall on the convex surface at point A. No, the ray travel through the another medium and meet at the point I. Okay, so the ray bends and passes through the second medium along the line AI. Now angle of refraction is T2. Okay, at the point A, the ray incident from this point, imagine one normal. This dotted line is normal. Okay, na? So the angle between the incident ray and the normal is called as angle of incidence, that is shown by theta 1. And at convex surface, the ray undergoing refraction. No, so when the ray enters from one medium to another medium, it is changing its direction. No, changing its direction and bending. Okay, so imagine one normal with dotted line. Okay, this refracted ray meet at the point I. Okay, so now the angle between the refracted ray and this dotted line normal is called as angle of refraction theta 2. Okay, now the two refracted rays meet at I and the image is formed here, formed there. Okay, first incident ray means the ray traveling through the principal axis not deviate, and the second refracted ray. Okay, second refracted ray and the ray which is travel through the principal axis, the two meet at one point I, that I is the image A. Okay, at this I the image will form. Okay, now the two refracted rays meet at I and the image is formed there. Let the angle made by the second refracted ray with the principal axis be gamma. Okay, so the angle made by the second refracted ray. Okay, second refracted ray once you observe, and with the principal axis, and with the second refracted ray. The second refracted ray forming an angle with the principal axis, no, that angle is gamma. Okay, and the angle between the normal and the principal axis is beta. Here one dotted line normal is there, no? Okay, that observe that normal line and principal axis. The angle between the normal and the principal axis. Okay, this angle normal making some angle with principal axis, no, that is called as beta. Okay, here is nothing but this from the object O, one ray traveling, the one ray pass through the principal axis as dot deviate, and one more ray that is making one more ray that is making some angle alpha with the principal axis and strike at the interface at A, okay, and undergo refraction that meet at the point I. This second refracted ray making angle with principal axis is, that is gamma, and here we are imagine one dotted line. That dotted line is making some angle with the principal axis, that is beta, and the angle between the refractor and normal is called as angle of incidence, that is angle of refraction, that is theta 2. Angle between the first incident ray and the normal is called as, that is angle of incidence, that is theta 1. Now PO is the object distance. O object is there, no? P to O distance is object distance. PI is the image distance. At I the image will form, no? That PI is the image distance. Okay. And P to C. Okay. From the center of curvature to, we should imagine one dotted line onto the curved surface, that is normal, no? That P to C distance is, what is that? Radius of curvature. That is showed by R. And N1 and N2 are the refractive indexes of two media. This N1 and N2. The two are the refractive index of two media. Can you establish any relationship between the above mentioned quantities? Yes, we can establish. How is that? Here. Okay. So here in the triangle ACO. So here one triangle ACO is there, no? ACO, once you observe, ACO, the triangle ACO, once you observe. Okay. From that we can write theta 1 is equals to alpha plus beta. Theta 1 is equals to alpha plus beta, means exterior angle is equal to the sum of the two opposite interior angles. No? Like that, from the triangle ACO we can write theta 1 equal to what we can write, alpha plus beta. And in the triangle ACI, once you observe the triangle ACI, okay, ACI, okay, observe the figure carefully. In that, from that beta is equals to what we can write, theta 2 plus gamma. So from this we can write beta minus gamma is equals to theta 2. Okay, according to Snell's law. What is Snell's law? N1 sin theta 1 is equals to N2 sin theta 2. Snell's law we discussed in 9th class now. From that we can write N1 sin theta 1 is equals to N2 sin theta 2. That is Snell's law. Now substitute the values of theta and T2 in the above equation. What we can write? N1 sin theta 1. Theta 1 what is there? Alpha plus beta equal to N2 sin theta 2. Theta 2 what is there? Beta minus gamma. Okay, like this it will come. This is equation number 1. Okay, that is equation number 1. If the rays move very close to principal axis, then the rays can be treated as parallel and it is called as paraxial rays. So here the rays are moving very close to principal axis. Here incident ray strike at the interface at one point A, no? Like that rays are move very close to normal. That rays are move very close to principal axis, that can be treated as parallel and that is called as paraxial rays. Then what happened? The angles of alpha, beta and gamma are becomes very small. Okay, that angles of alpha, beta, gamma very small. If the incident rays move very close to principal axis, that rays can be parallel to principal axis, that are called as paraxial rays, and the values of alpha, beta, gamma become very small. Then sin alpha plus beta is equals to, we can write alpha plus beta, and sin beta minus gamma is equals to, we can write beta minus gamma. Now substitute these values in equation number 1. What is that equation number 1? N1 sin alpha plus beta is equals to N2 sin beta minus gamma. So substitute this value in that equation. What are the values? Sin alpha plus beta is equals to alpha plus beta, and sin beta minus gamma is equals to beta minus gamma. Then what will come? N1 alpha plus beta, means in the place of sin alpha plus beta is equals to what we can write? Alpha plus beta. That's why we are written here. And N2 sin beta minus gamma. Sin beta minus gamma is equals to what is there? Beta minus gamma. It will come. Now multiply it, what will come? N1 alpha plus N1 beta equal to N2 beta minus N2 gamma. This is equation number 2. Okay. So here Since all the angles are very small, we can write tan alpha is equals to an by no, that is equals to alpha. So here we know that the right angle triangle, what are that? ANO and ANC and ANI we have, no? So from that we can write tan value like this. In a right angle triangle, the ratio of opposite side and adjacent side is known as tan. Okay, then tan is equals to opposite sides by adjacent sides. No, so here also we have three right angle triangle. No, what are the three right angle triangle? ANO and ANC, ANI we have. From that we can write tan theta is nothing but the ratio of opposite side by adjacent side. So tan alpha is equals to an by no, that is equals to alpha. Tan beta is equals to an by nc is equals to beta. Tan gamma is equals to an by ni, that is equals to gamma. Now substitute this alpha, beta, gamma values in the above equation number 2. Then what will come? Equation number 2, what? N1 into alpha plus beta is equals to N2 beta minus gamma, that equals to N1 alpha plus N1 beta, that equals to N2 beta minus N2 gamma. So then what will come? N1, this alpha, beta, gamma values will be there, substitute in the above equation. This alpha, beta, gamma value substitute in the above equation. Then what will come? N1 into an by no plus N1 into an by no. Why? Because alpha means an by no, that's why. Okay, next to N1 beta, no? N1 beta means N1 into beta, what is there? An by nc equal to N2 beta minus gamma is there, no? So equation number 2, what? N1 alpha plus N1 beta equal to N2 beta minus N2 gamma. So in that we should substitute the alpha, beta, gamma value. So then what will come? N1 into alpha an by no plus N1 into beta an by nc. Okay, an by nc, that is beta, equal to N2 beta, what is there? An by nc minus N2 gamma, what is there? An by ni, that is equation number 3. After substituting these values in the equation, then what will come? Then what will come? N1 into an by no plus N1 into an by nc plus N2 into an by nc minus N2 into an by ni will come. This is equation number 3. All the rays are move very close to the principal axis. The point N coincide with the pole of the interface P. All the rays are very close to principal axis. Then the point N coincide with the pole of the interface P. Okay, if the rays move very close to principal axis, then what happens? Then point N is there, no? That is coincide with the point B. Then the Ni, No, Nc can be replaced as Pi, Po and Pc respectively. Now substitute these values in the equation 3. We will get, what will come? N1 by Po plus N1 by Pc is equals to N2 by Pc minus N2 by Pi. How it will come? From this figure we have that, what is that? Po is equals to No by An we can write. Okay, Po is equals to No by An we can write. So then 1 by Po is equals to what we can write? An by No we can write or not? Yes, we can write. So once you observe the figure, Po is equals to, when the rays move very close to normal, that time Po is equals to what we can write? No by An. Okay, then 1 by Po is equals to what we can write? An by No. Okay, so An by No. Then what will come? N1 into, then what will come? N1 into An by N1 into An by No, it will come. Okay, plus at the same time what we can write? Pc is equals to Nc by An. Pc is equals to Nc by An. Then 1 by Pc is equals to An by Nc will come. 1 by Pc is equals to An by Nc will come. That's why we can write here N1 in, okay, 1 by Pc is equals to An by Nc will come. So in the place of An by Nc, what we can write? 1 by Pc, N1 into 1 by Pc. That's why here we got N1 by Pc. Next, Pi is equals to An by sorry, Ni by An. Pi is equals to Ni by An. Pi is equals to Ni by An. So then from that what we can write, 1 by Pi is equals to An by Ni we can write. So that's why here we are written N2 into 1 by Pi. Okay, substitute that values in the equation, then what will come? N1 by PO plus N1 by PC equal to N2 by PC. N1 here in the equation number 3, N1 into An by NO is there. So An by NO is equals to what we can write, 1 by PO, N1 into 1 by PO. Okay, next N1 into An by NC is there. Here An by NC is equals to what we can write, 1 by PC we can write. That's why what we can write, N1 into 1 by PC we are written is equals to N2 into An by NC is there. An by NC, what is there? An by NC means 1 by PC. That's why we are written N2 into 1 by C. Okay, minus N2 into An by Ni is there. N2 An by Ni. An by Ni means 1 by Pi we can write. So N2 into 1 by Pi. Okay, then what will come? N by PO plus N by PC is equal to N2 by PC minus N2 by Pi. Okay, so here what will come? N1 by PO plus here what is that? Pi minus N2 Pi is there. Transport this side. Then what will come? Plus N2 Pi it will come. Okay, N1 by PO plus N2 by Pi equal to N2 minus PC by, sorry, N2 by PC minus N1 by PC. Okay, so what equation we got? N1 by PO plus N1 by PC is equals to N2 by PC minus N2 by Pi is there. Okay, here minus N2 Pi is there, no, transfer towards the left side. Then what will come? N plus N2 by Pi it will come. N1 by PO plus N2 by Pi equal to P. Okay, here N2 okay, yeah. So here from the triangle O and P we can write PO is equals to NO by AN. Once you observe the figure, PO is equals to ON by AN we can write. Then 1 by PO is equals to AN by NO we can write. Okay, so at the same time PC, so PC equal to NC by AN we can write. Then 1 by PC is equals to AN by NC we can write. Okay, then Pi is equals to Ni by An we can write. Then 1 by Pi is equals to An by Ni we can write. Now we should substitute that values in equation number 3. Number 3, what is there? N1 into An by No plus N1 into An by Nc equal to N2 into An by Nc minus N2 into An by Ni. Is there no substitute in that? So N1 into An by No, what is there? 1 by PO is there. 1 by PO plus N1 into An by Nc is done. An by Nc, what is there? 1 by Pc. N1 into 1 by Pc we can write equal to N2 into An by Nc, what is there? 1 by Pc is there, right? Minus N2 An by Ni, what is there? 1 by Pi is there. Okay, then what will come? N by PO plus N by Pc equal to, here what we can write, N2 by Pc minus N2 by Pc minus N2 by Pi it will come. Okay, so from this what we can write? N1 by PO. Here right side N minus N2 by Pi is there, no, transport this side. Then what will come? Plus N2 by Pi. Okay, so N1 by PO, this minus N2 by Pi is there, no, transport this side. Then what will come? Plus N2 by Pi it will come equal to N2 by Pc. Next here left side what is there? Plus N1 by Pc is there, no, transport this side. What will come? Minus N1 by Pc it will come. Then what we can write? N1 by PO plus N2 by Pi equal to N2 minus N1 by Pc. Okay, now what is that? Okay, PO, Pi, Pc are object distance, image distance, radius of curvature. PO is equal to minus u. Why? Because opposite to incident ray. Pi is equals to V. Okay, that is in the direction of incident ray, that is plus V. Pc is equals to R. Okay, that is also in the direction of incident ray, that is plus R. Substitute this PO, Pi, Pc value in this equation. Then what will come? N1 by minus u. Okay, n1 by PO means PO is object distance. No, that's why n1 by minus u we are written, plus n2 by pi is there. No, n2 by pi means v, n2 by v equal to n2 minus n1 by pc means what, r. Okay, so n1 by okay, this equation also we can write n2 by v minus n1 by u is equals to n2 minus n1 by r. Okay, this is the equation. Show the relationship between radius of curvature, object distance, image distance, and refractive indexes n1 and n2. Yes or not? Here there are not there. What there? n2 by v minus n1 by u is equals to n2 minus n1 by r. V is the image distance, u is the object distance, n1 and n2 are refractive index, r is radius of curvature. This equation is show the relationship between in this all.